Here's the problem. You've got a movable pulley and a fixed pulley and two masses of M and 2M, and the problem wants to know what the accelerations are of each of these masses. So first thing it's good to do is to define what are the accelerations. So I just defined acceleration of this mass as A1 going up, which is natural. Acceleration of this mass, A2, which would be up as well, even though we know it might be dropping down, the A2 can just be a negative number. Now, it's really helpful to notice a couple things about this this double pulley thing. Double pulley because it's got this loop going through it twice. So this is mechanical advantage. So I don't know if you can see it or not, but just imagine there's no mass here at all and you're just trying to lift up a engine block or something heavy. As you pull this rope, you can pull it a long distance, but this doesn't actually move the whole distance that you pull this down. So that's what mechanical advantage is all about. It's more displacement here, less displacement here. So more force here, less force here. And I looked it up, and basically you figure out the mechanical advantage by, it's kind of a funny formula, but the number of chord sections that support the movable pulleys. Okay, call that number K. And this free chord doesn't count for anything. It's not really supporting a pulley. So actually, this is the only movable pulley, right? These other two are fixed. So how many sections of rope are supporting this pulley? 1, 2, 3, 4. Mechanical advantage is 4. So so that's one equation, and we need equations in here because we have the rope tension, T, is one variable, and the tension is the same throughout the rope, everywhere in the rope. It's the same tension. That's one variable. And then we have the A1 and the A2 that we want to find. So that's 3 variables. So we're going to need 3 equations. So the first equation is this. This comes from the mechanical advantage, and it's just, it doesn't, regardless of what these masses are, the motion of this is locked in with the motion of the end of this rope as 4-to-1. So whatever this acceleration is, it's going to be 1/4 of the acceleration here. So that's one equation. Then the other 2 equations we can just get by writing free body diagrams of the 2 masses. And this is very straightforward. So this mass, free body diagram, we have a downward force, mg, because of gravity always. And the upward force on this is the force, the tensional force in all these ropes. And there's 1, 2, 3, 4. And they're all the same. It's just 4T pulling up. So the equation for this mass is the sum of the forces on the left equals ma. So that would be the sum of the forces is 4T going up minus the mg, which is going down, equals ma, the mass, times that acceleration, a1. That's the free body diagram and the equation for mass 1. It's the same deal for mass 2, same technique. We have 1 tension pulling this thing up, and we have 2 mg pulling it down because the mass is 2m, and So that equation right there, equation 3 for this second mass, is just T minus 2mg equal 2ma2. That's F equals ma. It's a little confusing. The mass, the whole mass here is 2m, and then a2. So this is great because, like I said, we needed 3 equations because we have 3 unknowns, and we've got them right now. So now we know we're on the home stretch. We just have to do a bunch of algebra, and this could be done in a million different ways to get the answer, because you can substitute different things, but it all turns out. So I did it this way. I looked at equation 3, and I just rearranged it and solved it for t directly, and then did a little factoring. And then I rewrote equation 1 and to get a2, and then I put both of those into equation 2, and guess what? The only thing left was a1 and a bunch of numbers, so I was able to solve for a1. And because I knew a1, this other equation up here, equation 1 relates a1 to a2, so as soon as I knew a1, guess what? I know a2 right here. And you have to know the value of g, which is 9.8 meters per second squared. Thanks for watching.